Okay guys, let's move on to 14.2, Principle of Work and Energy, and this is almost the focus of this section on chapter 14 is the Principle of Work and Energy. Okay, what's happening here is we have, let's have a look at this diagram, we have a bunch of forces, the sum of the forces equal to a resultant force acting on a particle that's moving along this curve, and at this instant the direction of its motion is ds, right? It is moving in the tangential direction, same as the velocity direction. Okay, and recall that when we're trying to find the work done by the forces, we have to either get the component of the resultant force in the direction of motion, or we need the component of the displacement in the direction of the force, and that is just the dot product, or it's to use cos theta. Okay, so we start off with this Fr equals sum of the forces, but what we're really after is this. Okay, let's just see if this will work. There we go. What we're really after is the tangential force in the tangential direction. Again, why am I saying that? Because we're looking for the component of the force that's in the same direction as motion. Only that component of the force does any work. Okay, so let's start then. We know that the component of the resultant force, the cos theta component, is going to give us work, right? It's going to be a force that does work because it's in the same direction as that. Okay, and this is equal to the tangential force. Okay, I hope we get that. So the component in the direction of the displacement is equal to the tangential force. Okay, now if we write this, sum of the forces in the tangential direction, which is what we're interested in, is equal to the mass times the acceleration in the tangential direction. Okay, so this is just Newton's second law, straightforward. But the acceleration, right, if we use from first principles, recall that A ds equals V dv. So A is equal to V, if we rearrange this, dv ds. All right? Okay, so now we've got AT in terms of V dv ds. We can plug that in there. We are going to get this. Okay, V dv ds. And if we rearrange this, we're getting sum of the forces in the tangential direction, ds, is mv dv. All right? So this is looking kind of familiar. Force times a displacement. Okay? And so now what we want to do is we're looking at the principle of work and energy. So if we integrate, right, if we integrate this term and we sum up all the integrals of force times distance between S1 and S2, then that becomes the sum of our work. And if we also integrate this between V1 and V2, okay, this and then we solve for this, on the right hand over here we are going to get half mv2 squared minus half mv1 squared. And this over here, recall, I'm just going to rewrite it, Ft is the resultant force cos theta. Okay, so this over here is actually the sum of the integral of f cos theta ds, which is really our work from first principles. Okay, so this then becomes the sum of all the work done by all the forces equal to this change in kinetic energy. And so if we rewrite it here, it becomes U1 to 2, the sum of U1 to 2 is equal to T2 minus T1. Okay, and if you rewrite it, this is what you get. So all we're saying is the initial kinetic energy of the particle plus all the work done by all the forces is equal to the final kinetic energy, or the work done on the particle is equal to the change in the kinetic energy of the particle. Alright, now just to remind you, this is very helpful when we are solving problems including force, velocity and displacement. Okay, that's what they're saying over here. Alright, so say now you had a problem, you were given a problem that only had, say, force and, say, acceleration information in the problem. What would you need to do in order to obtain velocity and displacement? Well, you would need to solve for your acceleration, then you would need to go through this whole process, right? A equals dv dt, then if you had some time information you could solve for dv, and then you would need to integrate again, right? You would need to integrate again to get your velocity and then displacement, etc., right? So you could do it using chapter 13 techniques, but this in a sense bypasses this Newton's second law, so that you don't have to calculate acceleration directly. You can it almost bypasses this whole technique method and goes straight to velocity and displacement. Why? Because in this equation we have velocity, and inside here, if you recall, we've got velocity and displacement. Okay? So good luck. Cheers.